the main question I wanted to address with you was basically the extent that you see engineering in general becoming more data driven and sort of the role that test is playing in that future. And I'm just wondering if you have any sort of thoughts about that big picture sort of question.
Yeah, there's a lot to unpack in that question. Uh, I've used the term intelligence a lot, and for
Mhm.
me, I know that's a word that maybe gets thrown around casually. I don't mean it in a casual way. I mean, I define intelligence as an understanding of your product in a way that leads you to make better decisions to optimize its performance, cost, et cetera. And so when you think about how do I unlock a deeper understanding for every engineer on what their product actually does in the real world, so much of that information is stored in the measurement data that we take as a part of that design process. Now, there's a lot of steps in that. If you
Mhm.
talk to a lot of customers today and say, "What is your data strategy? What are you doing with all of the test and measurement data that you're taking?" I think what you'll find at a lot of companies is that it varies a lot from engineer to engineer and department to department. In some cases, it's not stored at all. In some cases, it might be on a single hard drive somewhere or distributed. That data may be in heterogeneous formats because one engineer thought to save it one way and another engineer thought to save it another way. And it's really hard for an individual engineer or a global corporation to really take a bunch of individual measurement data and turn it into that deep understanding that leads to you being able to make decisions that optimize your product and business performance. And so, step one is a little bit of governance. Frankly, it's not the most exciting thing in the world, but you've got to get your data curated and in one place and tagged with the right metadata so that you can find it and you can use it. And that's a hugely important step. With tools like System Link from NI and Optimal Plus from NI, we have various solutions that help customers do that today. But that's a basic governance issue. I think next generation tools can help you with that governance so that you can have that measurement data in the right context and findable and searchable and usable. And then we need to apply advanced analytics. Sometimes artificial intelligence is a great way to do that. And other times you just need basic statistical processes to help you optimize yield or find insight. But again, the end goal is an understanding that allows you to make a decision to help you improve your product and business performance. We've got to keep that end goal in mind. It is not just about the data. It's about understanding that unlocks decisions.
So you say that engineers are at sort of different stages of this transition, and I'm just sort of wondering from your perspective, like how quickly is progress being made on that front? Are engineers seemingly eager to make this jump or just, daunted by the complexity and that's slowing things down? And just how do you see that playing out, the transition playing out?
Yeah, I mean, of course, it varies by engineer to engineer and company to company. So step one is meet customers where they are. If you're a small engineer in a small company with a small lab, you don't need giant enterprise class solutions. That's not what you need. What you need is some basic tools to help you collect, to maintain, to manage that, and then to get insight from it. As you get to moving away from, say, what I'll call an individual's intelligence, and you get to a team level intelligence, you need collaboration tools and shared tools to help you work together as a group of people. And then as you get to larger global corporations, you need tools that help you see across your company, maybe through your own R&D facilities and into your contract manufacturers. And so everybody's at a different level of sophistication. I think we find that in a lot of cases, the semiconductor industry, based on the scale and the reach that they have, and really the economic benefit of small optimizations, they tend to be ahead. That doesn't mean that there aren't thought leaders across all of the different industries that we work on, but as a whole, there's a lot we can learn from the state of the semiconductor companies that are dealing with large scales of data and really getting good at making optimization decisions based on that data. And a core part of helping them has been the Optimal Plus solution from NI. It really has been fantastic for us to have that level of insight. But again, if you're a small at a small company and you're an engineer that just needs to manage a small set of data, we need tools that scale to that as well.
To kind of just, I guess, ground this maybe for some engineers, I'm wondering if you can maybe, do you have any examples that come to mind of data driving sort of engineering outcomes that they have in mind that they're trying to hit? I know you mentioned semiconductor industry and Optimal Plus, and maybe that's the best example to sort of walk through this, but can you kind of just paint us a picture of sort of how this is actually helping now, if that makes if
Yeah.
that makes sense?
So I mean, maybe I'll start with a big example and then give a smaller one
Okay.
for those engineers that may not have the advantages. But a couple of years ago at our NI Connect conference, we showed an application from NVIDIA. NVIDIA is obviously a world-class semiconductor organization. Here we're hearing more and more about NVIDIA every day, it seems. They work with a number of contract manufacturers to manage those parts. And in the past, they had engineers that would look after each contract manufacturer, and that's great. What we were able to do with them, though, in the Optimal Plus environment is to create this concept of a virtual engineer that could watch each contract manufacturer. And that virtual engineer could look at the measurement data and the statistics coming off each CM. They never take a break. They don't sleep. They don't get tired of petabytes of information and data. And we were able to make very significant improvements, having an intelligent agent effectively watch all of their processes at all of their contract manufacturers and bring aggregate insight back that allowed them to make process improvements to save a significant amount of money. And that's a great example of how an artificially intelligent tool can work on behalf of a human with a human, but to just keep track of vast amounts of information and data and actually lead to recommendations. And again, an understanding that helps you make a decision to improve your process or your end product. On a smaller scale, we see engineers that are just trying to match the requirements and deal with the complexity of, okay, I have a set of instruments. All of those instruments have specifications and guard bands. I have a device under test. It itself has a set of specifications. How do I reason about all of the different guard bands and uncertainties in my measurement systems that I know at the end of the day that the results I get are of sufficient quality? It's a very simple process, but it takes a lot of manual time. And if we can create tools that help a customer deal with complexities like all of the uncertainties in their system, that would be of great value to even a single engineer with a single measurement system.